Greetings, friends. Randall Nagy here again, and back to the BLT report. Let's take another bite out of those built-ins. And so far, we have covered a very good smattering of what we need to understand. And originally I thought we might cover these things one video per built-in opportunity. And to tell you the truth, they seem to have come together to group in a very logical way so that we could present many of them at the same time. And as we covered, is instance, is subclass, and has adder and set adder in this training, that's just the case because when we first take a look at what we've been talking about in previous videos, for example, the inheritance relationship between integer and Boolean, the inheritance between int and bool leads very naturally into the idea of using isInstance, where we would take an instance of an object and compare it to the class, or as I like to think about it, an instance of a pie as it would compare to the recipe for making a pie. So you remember that I love to say that everything in Python is an instance or an object, if you will. And if you remember, if we say we're going to check to see if the class definition for int is some type of object, well, it's a type object. Whereas if we were going to take an integer of 7, for example, we'll see that we'll be baking that recipe for an integer into a pie, and it becomes an instance of integer rather than simply a type definition. So as we use isInstance, for example, to see if an instance of Boolean, in this case true, is a type of int, believe it or leave it, we're going to see that, of course, they are related. However, if we reverse that around a bit, and we say isInstance, remembering that Python is going to take our 7 and convert it into an instance of an integer related to bool, we'll see, of course, that they are not. So it's obvious that isInstance is really one of those great ways that we can see if something we have created or our pie is related to what we needed to create it, either directly or somehow up the line. Remember that in Python, like many object-oriented languages, inheritance is one of those basic attributes that allow us to manage our code as well as reuse parents' operations. And so while bool is an int is an object, bool is also an object. But of course, working down that tree, object is not an int, and neither is int a Boolean. So while isInstance allows us to compare instances to their types, isSubclass completes the operations to allow us to compare classes, or if you will, recipes to recipes. Returning to our Python, of course, all we have to do is change isInstance to our class recipe definition to see, of course, that while bool is a subclass of int, that int is not a subclass of bool. Activating the help subsystem for both isInstance and isSubclass, we'll see that no matter which we use, of course, that isInstance as well as isClass will either take, as the name implies, a class or an instance or an object, and both will either take a single class or a tuple of classes. And when we have more than one set of recipes or classes, we're in an OR operation. In other words, what we pass in will have to be any one or another of the class definitions passed in, but not necessarily both. So the next deeper dive that's related to things we have talked about in previous videos, remember the built-in type explorer or example, if you would, we had zClass, and we discussed how that when we create a class normally, we're going to go through the static new dunder as well as the dynamic init dunder. so as to create things as we all understand. And if you don't understand how class creation works, you might want to consider taking Python 2000 Beyond the Basics on Udemy, as well as other educational content providers. Of course, the curious thing you remember is that we can use type so as to put a string name of our type or recipe, as well as passing a args or quargs so as to completely bypass normal dunder new and dunder init capabilities. But you have to ask yourself why we'd want to do that. And as I mentioned, there are many security as well as big data or huge data capabilities. For example, if I were to use a normal creation for a class, we could have the values there that we expect. Otherwise, we could put some special values inside of our class and create the class so as to say that we weren't normally created. We might have to take more dramatic security or perhaps data population activities because we use type so as to plug in values that otherwise would never be part of our class. So once we start pushing and popping things into our objects using either normal or type creation, of course, the next logical thing to cover would be the four adders, which will allow us to do pretty much the same things, as well as to delete what we've added, as well as test and return things that we have associated with instances of classes and other objects in Python. For example, the first set of the four adders, of course, would be the set attributes, or to check to see if an object has an attribute. And what I like to call the exceptional adders are get attribute, which will either return the member we've requested, which makes the request imperative. Otherwise, we're going to raise an attribute error because we're in an exceptional circumstance, just as we might be if we wanted to delete something from our object as well. Set adder is very easy to understand. It does pretty much exactly what we think it would. And it is the same thing as using a dot equals on a mutable object, as we see in the help system. But if we create an instance of Z, once again being an empty class simply with the pass defined, and we set an attribute A to be bingo, of course, whenever we indirect on Z.A, we'll see what we set. But in addition to simple settings of variables, we could also set complex functions. And even though Z is an instance of a class, note that we don't have to have a self parameter, and one will not be provided for us. For one example, we have a lambda function with no parameters. It's simply going to return howdy, in this case, whenever we call the lambda function or the function that we've associated with the A attribute of our class. So once we have things set, of course, has-adder will allow us to safely see if something is associated, in this case, to see if we have a lambda associated with an instance of Z, or if we have a B, which we haven't associated, of course, we would get another nice, safe, and happy false rather than true. Get-adder is one of those exceptional operations because of the four adders. If we're going to ask to get something, we're going to ask to retrieve whatever has been set. In this case, with our A, would return our lambda expression, which, of course, if we executed right away, as we see here on the bottom, would simply return the string associated with the function. If, of course, we're using get-adder to return whatever associated with something that doesn't exist, we're going to see our exception because, of course, returning true or false might actually be what we returned or set-adder had assigned. So the only appropriate response, of course, would be to raise our exception. So if setting an attribute is the same thing as saying the instance dot member x.y or z.a, of course, the delete attribute will be the same as using the del keyword for the same operation. In this case, we can simply associate A equals true and then delete the attribute, once again noting that if things don't work out as expected, we're going to have an exceptional operation, once again raising our attribute error whenever things have not been assigned as we expect. You may have noticed that no matter how we define our classes, that at the time of this recording, whenever you take a look at something we've created, you'll see something called a weak reference. And we're going to get a weak reference no matter if we create our Z using the way we expect to create our Z's by calling our dunder init after our static dunder new, or by using our type command. As a matter of fact, when we take the difference between a set of what we will create with one of our classes as opposed to something we would create with a built-in type, for example, an instance of the object class, we'll see that we only have three differences. One, of course, our module name, as well as, of course, our vars or dict that we will create, which wouldn't be part of object. Ultimately, the only other difference at the time of this recording is the dunder weak ref. So we might ask ourselves, what is a weak reference? And as you may expect, a weak reference allows us to associate things with our objects that will allow us to have our instance garbage collected or removed from, for example, either a security or perhaps a big data collection, so as to not only save memory, but also to make sure that when we change modules, weak referenced objects can be garbage collected. An advanced subject, and certainly one that doesn't require us to cover it in the core, and certainly an optional activity. For more information, go ahead and check out the Python documentation to understand what weak references are, why they're handy, but more importantly, how we can create stronger referenced objects and thereby becoming genuinely first-class objects using modern Python. So here we are at the review session, and unexpected as I had mentioned, we did indeed cover a good deal of content that brings us close to 25% of where we would like to be before covering all of these built-in features and functions. And perhaps a little unexpectedly, we do have a lot more PyQuest review questions that you can enjoy up to and including KA2039 for instance detection. The idea that is instance will either 1, check for an is-a relationship, 2, accepts exactly 2 parameters, 3, always requires greater than or equal to 1 class, 4, returns true or false, or 5, all of the above. KA2040, once again with class detection here, is subclass either 1, checks is-a relationships, 2, accepts exactly 2 parameters, 3, always requires 1 or more classes, 4, returns true or false, or 5, all of the above. KA2041 in class relations, another intermediate question. We should ask ourselves if all Python classes have 1, no common ancestor, 2, a common integral ancestor, 3, a common stir ancestor, 4, multiple inheritance, or 5, none of the above. KA3031 on Object Manager. We have to ask ourselves, how could we check for object membership? 1, by using inheritance. 2, by using duck typing. 3, using has-adder. 4, use get-adder. Or 5, either 3 or 4. That was easy. Hey, A3032 on object management once again has the same queries. Only this time we ask ourselves, how would we add object membership? In this case, would we either use inheritance, duck typing, use had-adder, or 4, use set-adder? Once again, either 3 or 4 of the above. KA3033 on object management asks us another advanced question to see if we understand that we use has-adder to either 1, create inheritance, 2, create duck typing, 3, safely check presence, 4, return the named attribute, or 5, all of the above. KA034 tests our object management and Pythonic powers by asking us the rather advanced question on why we use get-adder. Is it to 1, check for inheritance, 2, create duck typing, 3, safely check presence, 4, return a named attribute, or 5, all of the above. AA3035, another advanced question. We use set attribute to either replace an existing member, or assign new attributes, or safely check presence, or 4, attempt attribute removal, or 5, 2 of the above. Into the advanced 3036, we use delete attribute to 1, replace an existing member, 2, assign new attributes, 3, safely remove presence, 4, attempt attribute removal, or 5, none of the above. Into our advanced, once again, we have added KA3037 on type management, where we would now understand that we can use the built-in type function to either 1, change existing members, 2, create objects, 3, safely remove presence, 4, determine instance type, or 5, 2 of the above. Ultimately, in KA3038, our last question for this session would be an advanced one, which would ask us to identify if weak reference is either 1, a way to change existing members, 2, is a way to create objects, 3, safely removes members, 4, determines instance type, or 5, none of the above. Well, that wraps it up for our third session in the BLT PyQuesting activity. Stay tuned because we still have 75% of those built-in features and functions to look forward to. And if you haven't had a chance to go over to Udemy yet and sign up for my free PyQuest Python primer, and if you're a beginning or a new Pythoneer, I'd encourage you to go over and do that now, because just like our BLT report, software development makes a very poor spectator sport. And the more you learn, the more you earn in this modern software development world. Thanks for watching. And once again, see you when you go pro. Take care.